We are now going to be talking Chapter 11 of the Uniform Plumbing Code, and this is all about storm drainage. It's one of my favorite chapters. It's not that long. It's much like the other previous 3 or 4 chapters where it was just a few pages long. But there's some pretty good information in here. So let's go ahead and get right to it, shall we? Storm drainage. Where required. Roofs, paved areas, yards, courts, courtyards, vent shafts, light wells, or similar areas having rainwater shall be drained into a separate storm sewer system or into a combined sewer system where a separate storm sewer system is not available, or to some other place of disposal satisfactory to the authority having jurisdiction. In the case of 1 and 2 family dwellings, stormwater shall be permitted to be discharged on a flat area, such as a street or a lawn, so long as the stormwater shall flow away from the building and away from adjoining properties, and shall not create a nuisance. So whoever, who wants to have a nuisance, right? Stormwater drainage to sanitary sewer is prohibited. So now we have stormwater shall not be drained into sewers intended for sanitary drainage. Pretty self-explanatory, and the reason being is you don't want the stormwater to overtax the sewer system. The sewer system is not designed to withstand the volume that comes from a storm event. It has to be a separate system. The materials being used, pipe, tube, fittings conveying rainwater shall be of such material and design as to perform their intended function to the satisfaction of the authority. Conductors within a vent or shaft shall be of cast iron, galvanized steel, wrought iron, copper, copper alloy, lead, Schedule 40 ABS, Schedule 40 PVC, stainless steel 304 or 316, provided that they're not less than 6 inches above ground. So they have to be above ground for that stuff. Or other approved materials, and changes in direction shall be in accordance with the requirements of Section 706. So we know that Chapter 7 is sanitary drainage. We're utilizing the same materials and the same material requirements that came from that chapter, okay? ABS and PVC. Now we're going to talk about fire stop protection, which is Chapter 14, and we'll just kind of blow right through that because it essentially says that you have to be regulated enough for the materials so that they don't spread a fire between fire corridors, and they have to be rated as such. Copper and copper alloys. Joints and connections in copper and copper alloy pipe and tubing shall be installed in accordance with Section 705.3. Again, it refers back to Chapter 7. All of these chapters that pertain to any type of drainage or traps or interceptors or indirect waste, the vents, so all of these chapters always revert back to Chapter 7. Always go back and reference Chapter 7 because that is the chapter to go off of. Conductors installed above ground in buildings shall comply with the applicable standards referenced in Table 701.2 for above ground drain waste and vent piping. And just to reiterate, conductors, back into Chapter 2, here, you know what, let's do that. Let's go back to Chapter 2 real quick and we'll talk about conductors and what they actually mean. Let's see here. Oh, wow, check it out. Almost made it right on the money. Conductor. A pipe inside the building that conveys stormwater from the roof to a storm drain, combined building sewer, or other approved point of disposal. So the overhead piping inside a building is not necessarily the storm drain. That is the storm conductor. The conductor transfers it to a storm drain. The storm drain is the underground portion of the storm piping that's inside the building. And then when you get 2 feet outside the building, it's called the storm sewer. So back down to conductors. and it's telling you that it's all the same materials, what we were just talking about, what we need to use above ground, below ground, 304, 316, all above 6 inches, everything is the same. Same thing for leaders. Leaders, again, revert back to table 701.2 for above ground drain waste and vent piping. Except now you can use aluminum sheet metal, galvanized sheet metal, or copper sheet metal. Because the leader, if we were to go back to chapter 2, is the exterior or outside, it's like a rain gutter, okay? That's what the leader is. That's the stuff that's outside. Underground building storm drains. Underground building storm drains shall comply with the applicable standards referenced in Table 701.2 for underground drain waste and vent piping. Building storm sewers. Table 701.2 again. Subsoil drains. Now we're getting into something a little different. Okay? A subsoil drain shall be open, jointed, perforated, or both, and constructed of materials in conformance with the table below. So the table below is PE, PVC, and vitrified clay extra strength. So we have polyethylene, polyvinyl chloride, or vitrified clay. Okay? The subsoil drain is what wraps around the building. We're going to talk about that. Okay? And it takes the groundwater and gets it away from the building so it doesn't deteriorate the building substructure. Expansion joints or sleeves shall be provided where warranted by temperature variations or physical conditions. Subsoil drains shall be provided around the perimeter of a building having a basement, cellar, crawl space, or floor below grade. Such subsoil drains shall be permitted to be positioned inside or outside the footing, shall be of perforated or open jointed approved drain tile or pipe, not less than 3 inches in diameter, so it has to be at least 3 inches, and shall be laid in gravel, slag, crushed rock, approved 3/4 inch crushed rock, recycled glass aggregate, or other approved porous material with not less than 4 inches surrounding the pipe. The filter material, or filter media, shall be provided for exterior subsoil piping. So here we have a pipe. Here, let's see. Let's do this. Sketch time. Subsoil pipes. So what they're talking about essentially is, so we'll say you have like a footing, right? And then bring it up a little bit more. And we have ground, right? We have, this is grade. Oh, you can't see that, sorry. So that's the grade. Down here, the footing lies, and let's say that's inside the building here, we have, like a basement or something right here, okay? And this wouldn't actually be grade. Okay. Basement. Okay. This area here gets a 3-inch minimum pipe with rock around it. Okay. And this rock, and this is all wrapped around filter fabric. So any groundwater that comes down, like here, and let's say wicks down, it's going to collect inside here. And it's going to get into this, and it's going to flow out, okay? Now the pipe itself is going to have perforated holes on it, okay? So that the water can come into it as it drains out. And that goes all the way around the exterior building, okay? Wherever there's any kind of like a basement or anything like that. Okay? And, oh yeah, the thickness of that filter. So this filter right here that filter, this guy right here, all that filter media, the rock, it has to be at least 4 inches all the way around. Okay, so the total diameter of this is, well, you got 4 inches, so that's 8 plus 3, so that's about 11 inches total in diameter. Okay. Subsoil drains shall be piped to a storm drain, to an approved water course, to the front street, curb, or gutter, to an alley, or the discharge from the subsoil drain shall be conveyed to the alley by a concrete gutter. Where a continuously flowing spring or groundwater is encountered, subsoil drains shall be piped to a storm drain or an approved water course. The sump. So if it's not possible to convey the drain by gravity, and we're still talking the subsoil drains shall discharge to an accessible sump provided with an approved automatic electric pump. The sump shall be not less than 15 inches in diameter. So now we're talking about the actual hole, which is called the sump. It's 15 inches in diameter, no less. 18 inches in depth. Can it be deeper? Sure. And provided with a fitted cover. The sump pump shall have an adequate capacity to discharge water coming into the sump as it accumulates to the required discharge point. What's next? Let's find out. It's over here. And the capacity of the pump shall be not less than 15 gallons per minute. So if you might recall back in chapter 7 when they were talking about the discharge of the sump for sanitary drainage, it was a minimum 20 gallons per minute. This is the storm drain, and it's a minimum 15 gallons per minute. Okay, so the discharge piping from the sump shall be not less than 1.5 inches and have a union or other approved quick disconnect assembly to make the pump accessible for servicing. So it's a little bit different. 1.5 inches instead of 2 inch, 15 gallons per minute instead of 20. So, but it's mostly because it's not conveying any solids like the regular sanitary drainage would. Okay. Now we have splash blocks. Here, let's try and focus this in a little bit. It looks like it's kind of going out of whack. Yeah, a little bit better. Splash blocks. For separate dwellings not serving continuously flowing springs or groundwater, the sump discharge pipe shall be permitted to discharge onto a concrete splash block with a minimum length of 24 inches. This pipe shall be within 4 inches of the splash block and positioned to direct the flow parallel to the recessed line of the splash block. And then you have a backwater valve. Subsoil drains subject to backflow, where discharging into a storm drain, shall be provided with with a backwater valve in the drain line so located as to be accessible for inspection and maintenance. So what they're talking about there, we'll bring this over here and we'll quickly do a little deal. So here we have our subsoil drain. Okay. And we're going to put in a backwater valve. Okay. That's the symbol I'm going to use for a backwater valve. It's pretty much the symbol for a check valve, which is the same thing. And this is going to tie in to a storm drain. And then the storm drain will come over and tie into the storm sewer. Which is typically located right outside the building. This is here because if this storm sewer were to ever back up and come down the line, the last thing you need, because this guy has perforated holes all through it, the last thing you need is storm water to come in here and go through the holes and flood out around the foundation. So this guy prevents any of this stuff from going back into it. That's what they're talking about as far as the backwater valve. The open area. Nothing in section 1101.6 shall prevent drains that serve either subsoil drains or areaways of a detached building from discharging to a properly graded open area, provided that they do not serve continuously flowing springs or groundwater. The point of discharge is not less than 10 feet from a property line. So you have to be at least 10 feet from a property line if you want to discharge one of these bad boys out. And it is impractical to discharge such drains to a storm drain, to an approved watercourse, or to the front street curb or gutter, or to an alley. Okay? Building subdrains. Building subdrains located below the public sewer level shall discharge into a sump or receiving tank, the contents of which shall be automatically lifted and discharged into the drainage system as required for building sumps. And again, it's not a sanitary drainage system that we're talking about. It's the storm drainage system that we're talking about, okay? Areaway drains. Open subsurface space adjacent to a building, serving as an entrance to the basement or cellar of a building, shall be provided with a drain or drains. The areaway drain shall be no less than 2 inches in diameter for areaways at a maximum of 100 square feet, and shall be discharged in the manner provided for subsoil drains not serving continuous flowing springs or groundwater. Areaways exceeding 100 square feet shall not drain into subsoil drains. The drains for areaways exceeding 100 square feet shall be sized in accordance with Table 1103.2. Window areaways at a maximum of 10 square feet in area shall be permitted to discharge to the subsoil drain through a 2-inch diameter pipe. However, any window areaway exceeding 10 square feet in area shall be handled in the manner provided for entrance areaways, which was what we just talked about. Filling stations and motor vehicle washing establishments. Public filling stations and motor vehicle washing establishments shall have the paved area sloped toward sumps or gratings within the property lines. The curbs not less than 6 inches high shall be placed where required to direct water to the gratings or the sumps. In other words, all those filling stations, anything that has anything to do with oil, they don't want that going down the storm drain or storm sewer. So you have to sit there and slope everything inward. All the car washes, all those places, they all have to slope inward. Okay? Okay. Paved areas. Where the occupant creates surface water drainage, the sumps, gratings, or floor drains shall be piped to a storm drain or an approved watercourse. Again, paved areas, they want all of that rainwater collected. Okay? Roof drains. Roof drainage shall comply with the following couple of sections here. Your primary roof drain. Roof areas of a building shall be drained by roof drains or gutters. The location and sizing of the drains and gutters shall be coordinated with the structural design and the pitch of the roof. Otherwise, unless otherwise required by the authority having jurisdiction, roof drains, gutters, vertical conductors or leaders, and horizontal storm drains for primary drainage shall be sized. And this is the cool part. Okay, this is why I like sizing storm drains. Roof drains, gutters, vertical conductors or leaders, and horizontal storm drains for primary drainage shall be sized based on a storm of 60-minute duration and a 100-year return period. And so you can go back to table D 101.1, which is in Appendix D, for 100-year 60-minute storms at various locations. And everything is based entirely on that. And the cool part about that is you can have 2 identical buildings, one from San Diego and one in Palm Beach, Florida. The storm drain size is going to be completely different because it's based on how much rain it gets. It's pretty cool. Secondary drains. Secondary or emergency roof drainage shall be provided by one of these methods, the following below here. You have a roof scupper or an open side. Secondary roof drains shall be provided by an open-sided roof or scupper where the roof perimeter construction extends above the roof in such a manner that water will be entrapped. So the such a manner part is, here we have a rooftop, right? You throw a parapet wall up on this bad boy, right? And this parapet wall, now it collects water, so water can collect in here. So you need to open up the side. Let's say that we have a roof drain right in here, okay? We want, in this case, to open up the side of one of these parapets and allow the rainwater to pour out, okay? So that's what we're talking about in this case. We run the primary roof drain. Now for the secondary, we're going to open up the side. We will be right there, okay? An open-sided roof or scupper shall be sized to prevent the depth of ponding water from exceeding that for which the roof was designed as determined by section 1101.12.1, which is the sizing parameters based on rainfall. Scupper openings shall be not less than 4 inches high and have a width equal to the circumference of the roof drain required for the area served, sized in accordance with table 1103.1. So let's say we have, it says, first of all, the scupper opening shall be not less than 4 inches high. So we have to have at least a 4-inch high deal, right? Now we're sitting this elevation here, up this way is 4 inches, okay? So that part is set. But how wide is this? Well, let's say that this guy over here, let's say it's a 4-inch roof drain, okay? Okay, RD for roof drain. This is 4 inches high. How wide does this have to be? Well, the area of a 4-inch circle, because like I said, this is a 4-inch roof drain. The area of that 4-inch circle is 12.56 square inches. We need to be minimum 12.5 square inches. In order to do that, I have to run this bad boy over how much? At least 3.14 inches, okay? So usually they'll just go 4 inches up and, you know, run it over 4 inches wide, and that gives you the equivalent spillover. And that's what they're talking about. So we've finished that one. Now the other alternative is to actually do another secondary roof drain. So the first one is to run a scupper or open up the side. The second one, oh, by the way, the scupper. The scupper is pretty much just doing a 4-inch, I'll see if I can draw this right. I don't like drawing scuppers, they suck. So this is pretty much what a scupper looks like. Okay, kind of like a tongue. Matter of fact, a lot of people call them cow tongues. So this is the pipe right here coming out. So there you go. And usually this is the flange part right here. So they'll have a couple of little deals where you can screw it in, and sometimes they'll even put one on right here. So, but that's what you got. That's what it is right there. You know, and all the waste comes pouring out, and it just goes out the side. So if this is a 4-inch drain, that's going to be a 4-inch scupper. And usually when these scuppers get discharged, they're not up on the roof. They usually run those down, and we're going to get into that. But you can put one of those scuppers on the side. Like you can put those on the side just like the opening. Secondary roof drains shall be provided. Secondary roof drains shall be located not less than 2 inches above the roof surface. The maximum height of the roof drain shall be a height to prevent the depth of ponding water from exceeding that for which the roof was designed, as determined by section 1101.12.1. The secondary roof drain shall connect to a piping system in accordance with section 1101.12.12, 1101.12.221 or 12.222. 12.222. Yeah, a lot of twos. So, in other words, the secondary roof drain ties in by one of these two methods, okay? But like I said, let's talk about this real quick. The secondary roof drain shall be located not less than 2 inches above the roof surface. So we have a primary roof drain, and then we have a secondary roof drain that's 2 inches higher than that. And they're 2 inch higher. The way they alleviate that and take care of that is you put in two identical roof drain bodies, right, on the roof. So here we have this roof, and you have the roof drain. So here's the ring for the roof drain, and we'll put this up here, and there's your roof drain, right? It's got the ring around it and everything, and all the water comes to it. The secondary one, which sits next to it, and we'll get into the distances in just a second, but the secondary is going to be right here, okay? And it's going to look very similar to the actual roof drain itself, with the exception that it has this lip around it, and this lip is 2 inches high, and it goes all the way around. It's solid. So this guy takes everything through, right, and everything goes into it. This guy is only going to take it if the level reaches up to 2 inches, and that's your overflow, and that'll come in and take it. When you see this, that means, oh my God, I've got more than 2 inches of standing water up on the roof because it's not handling it. All right, so separate piping system. So now we're still talking about the secondary deal. We're still talking about this guy right here. Still talking about this guy. Two different ways to do it. One is this one, separate piping system. The secondary roof drain system shall be a separate system of piping independent of the primary roof drain. The discharge shall be above grade in a location observable by the building occupants or maintenance personnel. Your secondary roof drain system shall be sized just as the primary, okay, just the exact same way. So you're discharging it above grade. So that means you're just stuffing a pipe out the side of the building where everybody can see it. And if water comes out of that, it means you got a problem with your primary. That is the way most commercial buildings have their piping ran. Now, I have done this next one, and I am not proud of that, but it is approved. You can do it. I don't agree with it. The combined system. The secondary roof drain shall connect to the vertical piping of the primary storm drain conductor downstream of the last horizontal offset located below the roof. The primary storm drain system shall connect to the building's storm water that connects to an underground public storm sewer. The combined secondary and primary roof drain system shall be sized in accordance with section 1103 based on double the rainfall rate for the local area. So what I don't agree with is the fact that I'm taking a primary. Let's go back to this. So I'm taking a primary. Let's say this bad boy comes over and runs over here, and it picks up another one from over here or something or whatever, and it comes over, and then it's going to drop down, right? So that runs off in the distance and goes and picks something up, and then it comes down and it drops down, right? This thing said See if I can get there quick enough. The secondary roof drain shall connect to the vertical piping of the primary storm drain conductor downstream of the last horizontal offset located below the roof. The last horizontal offset below the roof. Well, here's your roof. The last horizontal offset below the roof is right here. So this guy, the secondary, has to come down, come over, and tie in right here. This is the combined system. And the pipe should look a lot better than that in reality. So, you know, don't expect your pipe to look as good as this one. It'll look, you know, better, actually. So, yeah, it ties in right here. The problem with this is once this leaves here and this ties into the primary, guess where the primary goes? It goes to an approved storm sewer system. So if my primary is no longer flowing and it's not draining anymore and the secondary picks up on it, I'm never going to know that the secondary is actually working and doing its job. I'm never going to know that there may be something over here. And believe me, this happens all the time where a plastic bag, kind of looks like a shirt, but a plastic bag, and we'll put like a little, you know, Target symbol on it, you know, like a Target bag. They have 3 deals. Okay, so like a Target plastic bag is floating in the breeze, and it can land on top of this grate, and this will cover it, consume it, and the water won't drain on it. And I'll never know. And this guy, which is the overflow, which is your secondary, is doing all the work. But what happens if another bag, you know, and we'll call this one the Walmart bag. What if the Walmart bag comes in and consumes this and just falls right on top? Now I got this Target bag sitting on top of this drain. I got the Walmart bag sitting on top of this drain. All of a sudden, nothing drains. The worst part about this is by the time you get to the roof, if the parapet's 5 feet high, you're looking at, you know, 2.5, 3 feet worth of water in the corner of the roof. Believe me, that roof is not designed to withstand that much weight. Have you ever tried picking up a 5-gallon bucket of water? It's heavy, okay? It's very heavy. Multiply that, okay? It's not safe. So that I don't like the combined system, okay? I just don't. I don't like it at all. Cleanouts. Cleanouts for building storm drains shall comply with the requirements of Section 719 of the code. Again, it reverts all the way back to Chapter 7. So a lot of the plumbers won't put cleanouts in on the system, and they feel that you don't have to. The only places you really do, it's on the first floor, because it says in Chapter 7 that you don't need anything above the first floor, right? So, but they're talking building storm drains anyways, and a building storm drain is the first floor. Rain leaders and conductors. Rain leaders and conductors connected to a building storm sewer shall have a cleanout installed at the base of the outside leader or outside conductor before it connects to the horizontal drain. Rainwater sumps. Rainwater sumps serving public use occupancy buildings shall be provided with dual pumps arranged to function alternately in the case of an overload or mechanical failure. The pumps rated at 600 volts or less shall comply with UL 778 and shall be installed in accordance with the manufacturer's installation instructions. Traps on a storm drain. Leaders in storm drains, where connected to a combined sewer, shall be trapped. Floor and area drains connected to a storm drain shall be trapped. Now we have a combined sewer. A combined sewer is only allowed when the authority having jurisdiction approves it, and it's both the stormwater and the sanitary sewer. This is where the code kind of contradicts itself a little bit, because you remember in the beginning of the chapter we talked about we can't do that. Well, now we're talking about if you do it, you have to have a trap. So all of the storm drains up on the roof have to be built in with traps. Exception: traps shall not be required where roof drains, rain leaders, and other inlets are at locations permitted under Section 906 of vent terminations, where not required. And that exception is actually kind of cool, because if you do have a combination sewer system and you have that roof drain up there, why would you trap your roof drain if it's sitting right next to a sewer vent? Because the roof drain itself is going to be venting out sewer gas anyways, because it's combined with the sewer system. Where not required, no trap shall be required for a leader or conductor that is connected to a sewer carrying storm water exclusively. So you don't need to trap any of those roof drains or roof drain bodies. Trap size. Traps, where installed for individual conductors, shall be the same size as the horizontal drain to which they are connected. So if I have a, let's say a 4-inch roof drain body, vertically 4-inch is quite large. Once I go horizontally, I may have to increase my pipe size, because the volume coming down vertically can be, I can handle a 4-inch volume vertically, but once I go horizontally, that 4-inch volume cannot stay maintained and it'll start to back up. So we have to upsize the horizontal. The horizontal piping is always going to be larger than the actual roof drain body itself. Not always, okay, but it'll never be less, I'll tell you that. Method of install of a combined sewer. Individual stormwater traps shall be installed on a stormwater drain branch serving each stormwater inlet, or a single trap shall be installed in the main storm drain just before its connection with the combined building sewer. Such traps shall be provided with an accessible cleanout on the outlet side of the trap. Leaders, conductors, and connections. Leaders or conductors shall not be used as soil, waste, or vent pipes, nor shall soil, waste, or vent pipes be used as leaders or conductors. Leaders installed along alleyways, driveways, or other locations where exposed to damage shall be protected by metal guards recessed into the wall or constructed from the ferrous pipe. So any leader installed along an alleyway or a driveway or any other location exposed to damage shall be protected by a metal guard recessed into the wall. or constructed of ferrous piping. And most of you have seen this, where we have a structure and we have a gutter system, and so here's the parapet wall. Oh God, that's horrible. Okay, so here's your parapet wall, and we'll say the wall is coming down, right? So the wall comes down this way, and then you have the drain leader, which comes out, juts out the wall like this, right? Comes down, and we'll say that it receives all of this, you know, back here, there's a little hole over here, right? So this is where the water comes out of the roof and into this big, huge deal. And then this comes down and pipes down into a smaller pipe, reduces down, and comes down. So this is my leader, and it's just happens to be, we'll go down that far. And then it pipes out and comes out like so, right? and then the water comes spewing out. Okay? And then our finish floor is right here. So we'll say that's your building right there, right? Okay. This, if it's coming out the building, we have to build or put we either put a bollard in to protect it. Okay. You know, those posts, or we build a deal around it, right? Where it comes out. And, you know, protects it, right? And it keeps people from hitting it. So that's what they're talking about that. If you go into any alley and you see one of those leaders coming down the side of the building, that's pretty much what they're talking about. Combining storm with sanitary, here we go. The sanitary and storm drainage system of a building shall be entirely separate, except where a combined sewer is used, in which case the building storm drain shall be connected in the same horizontal plane through a single Y fitting to the combined building sewer, not less than 10 feet downstream from a soil stack. So that one, yes, screw it, there's enough room. It's just going to be drawn really small. So this guy, this is the building drain coming down, runs across, right? So this is our soil stack, okay? So that's your soil stack. And then we can't tie into this, and we'll say that that's a soil stack, and we'll say that this is a soil stack. Okay, so this is the last downstream soil stack before it goes to sewer. We have to go a total of 10 feet before I can tie in the same plane. So this guy can tie in, no, we'll go this way. This guy can tie in at a Y, 45, okay, in the same plane. If this is like 4 feet down, this is 4 feet down, okay, and this will be my storm, okay. So that's what they're talking about. This can tie in, but it can't tie in unless it's in the exact same horizontal plane and at least 10 feet away from the sewer stack. A lot of little drawings in this one today, huh? Okay, so that's that one. And roof drains. Applications. They shall be constructed of aluminum, cast iron, copper, or not more than 15% zinc, lead, nickel, bronze, stainless steel, ABS, PVC, polypropylene, polyethylene, or nylon. The dome strainer. Roof drains shall have dome strainers. Exception. A roof drain strainer for use on a sun deck, parking deck, or similar area that are normally serviced and maintained shall be permitted to be of the flat surface type. Such roof drain strainers shall be level with the deck. So this is what they're talking about as far as the strainers go. That's a strainer. Okay, the little dome, that's what that is. That's a roof drain strainer. Roof drain flashings. The connection between the roof and the roof drain that pass through the roof and into the interior of the building shall be made watertight by the use of a proper flashing material. So now what they're talking about is those roof drains are actually bolted in. They're tying into the piping underneath the roof, but they still have to be bolted into the roof structure. Then it gets roofed over after they lay down a roof flashing. Okay, it's all part of the buildup in the roofing. And this is the material that you are allowed to utilize. There's also a few other things you can use, but one of them is where lead flashing material is used, it shall be not less than 4 pounds per square foot, which means a piece of this that is 12 inches by 12 inches is freaking 4 pounds. and you get a whole roll of that lead flashing, it weighs a couple 100 pounds. It's flipping heavy. And then the copper flashing is no less than 12 ounces per square foot. So it's not even a pound. Because I believe a pound is 16 ounces, I think. I could be wrong. I'm just a plumber. Okay. The size of a leader, conductor, and a storm drain. We're going to go through this quickly because this is more towards the plumbing 3 end of more of a plumbing 3 thing. Vertical conductors and leaders shall be sized by the maximum projected roof area from table 1103.1. The size of your building storm drain or building storm sewer or horizontal branches shall be based on the maximum projected roof or paved area to be handled. So in other words, you have an entire flat roof with multiple roof drains on there. It's whatever that roof drain is receiving, because you can actually pitch a flat roof to go to one side of the roof or the other. And it's only what that roof drain itself is going to handle. The size of the roof gutter. Size of a semicircular gutter shall be based on the maximum projected roof area and table 1103.3. So there's different tables, and we'll get to those tables in a second because we're almost, believe it or not, we're not too far away. This section cracks me up. Now, I'm not going to get too technical on this because this is plumbing 3 stuff, but I absolutely love this section. Where vertical walls project above a roof to permit stormwater to drain into the roof area below, the adjacent roof area shall be permitted to be computed from table 1103.1 as follows. So what we're talking about, and we'll go back to this one here, what we're talking about is this wall right here. So a roof drain receives the discharge. So let's say that this roof is split and everything drains down this way to our roof drains that are right here. And then this one drains out this way to the 2 roof drains that are over here. Okay? One's primary, one's secondary. Let's say that this parapet wall here is the only thing that's up. Okay? So that's all you see is this guy. Well, rainwater is going to collect on this, right? And then it's going to come down onto the roof. And so we have to accommodate for whatever rainwater comes and hits this. This is what we got for one wall. Okay, and that's the one wall I was just showing you. Add 50% of the wall area to the roof area figures. Back to the drawing. Okay, so let's say this is 100 square feet. Let's call it 1,000 square feet. That's a little more realistic. So we have 1,000 square feet here. Let's say this is 100 feet long, right? And 3 feet high. It's small. 100 by 3 is 300 square feet, right? So this little sidewall is 300 square feet. I have to take 50% of that, which means it's going to be 150 square feet. And I'm going to add it to this 1,000 square feet for this one. So these roof drains are actually receiving 1,150 square feet. Okay, that's what they're talking about. And then we go through and we size it based on all kinds of stuff. This is where it gets really funny. Okay, for 2 adjacent walls of equal height, add 35% of the total wall area. So now we've got 2 that are adjacent to each other. These 2, and they're both identical. So these 2 that are identical to each other, we're going to add 35% of that combined. So we have 300 this way, and we'll say we have 300 this way. Okay, so then we're just going to add we're going to add 35% of 600, and then you're going to add it to this. So 600, I don't have a calculator. We'll do it later. Or, you know what? Let's just do it. Screw it. I've already brought it up. So we have 600 square feet. And we're going to take 35% of that. So we're going to multiply it by 0.35. That's a 0, 0, and then 30, and then 18 plus 3 is 21. So we have 210. So instead of 1,150, we have 1,210 square feet. Okay. The rest I'm not doing any examples of. I'm just going to tell you how ridiculous this actually starts to get. Number 3. And these are all instances where we have all these little parapet walls above the roof, and we have to make accommodations for whatever rainwater's coming down. For 2 adjacent walls of an unequal height, add 35% of the total common height and 50% of the remaining height of the highest wall. So the common height, which is the height of both that are equal to each other, and then add 50% of whatever's higher than that. So if one wall is 3 feet, the other wall is 5 feet high, I'm going to do 35% of the 3 foot high part, and then the remaining 2 feet, I'm going to take 50% up. And that's the surface area of that. Number 4, 2 opposite walls of the same height, no additional area. Number 5, because they offset each other. They cancel each other out. Number 5, 2 opposite walls of differing heights, add 50% of the wall area above the top of the lower wall. Again, I have 2 opposite walls. So I have one wall, I have this wall, and then on the other side I have another wall. This one's 3 feet, this one's 5 feet. I'm only going to take 50% of the one that's 2 feet above the 3 feet, because the 3 feet cancel each other out. 2 feet higher than that, that's all new. I got to do 50% of that. Now we have walls on all 3 sides. Add 50% of the area of the inner wall below the top of the lowest wall, plus an allowance for the area of the wall above the top of the lowest wall, in accordance with section 1103.43 and section 1103.45. It starts to get more ridiculous. So then we go to number, I believe there is a number 7, and yes there is, because this is where it gets really interesting. And again, we'll explain this a lot more when we get into plumbing 3. Now I have walls on all 4 sides, which is more than likely going to be the case if you have a parapet wall. No allowance for wall areas below the top of the lowest wall. So if all walls have at least 3 feet, we're going to cancel out the 3 feet. Add for the areas above the top of the lowest wall in accordance with the sections prior, So it starts to accumulate. Once you start to do it, it's not that bad, but it's still, I just find it, if you're not paying attention, I find it extremely confusing. The bottom line is you're either taking 50% or 35% of that surface area, depending on what you got going on. Values for continuous flow. Where there is a continuous or semi-continuous discharge into the building storm drain or building storm sewer, as from a pump, an ejector, air conditioning plant, or similar device, 1 gallon per minute of such discharge shall be computed as being equivalent to 24 square feet of roof area, based upon a rate of rainfall of 4 inches per year. And that's a continuous or semi-continuous discharge into the building storm drain. Okay? Controlled flow roof drainage. Instead of sizing the storm drain system in accordance with section 1103, which most people do, the roof drain shall be permitted to be sized by controlled flow and storage of stormwater on the roof, provided the following conditions are met. So now we're talking about keeping water up on the roof for an extended period of time. We have to make sure that these conditions are met if we're going to do it. The water from a 25-year frequency storm shall not be stored on the roof exceeding 24 hours. So we cannot keep what's projected on the roof more than a 24-hour period. During the storm, the water depth on the roof shall not exceed the depth specified in table 1105.1, which is over here, right? So we'll get to that in a second. So the water, now we're looking at water depth, and we can't keep it any deeper than what it tells us to. Not less than 2 drains shall be installed in the roof area of 10,000 square feet or less, and not less than one additional drain shall be installed for each additional 10,000 square feet of roof area exceeding 10,000 square feet. Each roof drain shall have a pre-calibrated, fixed, non-adjustable, and proportional weir or notch in a standing water collar inside the strainer. No mechanical device or valve shall be permitted. The pipe sizing shall be based on a pre-calibrated rate of flow of the pre-calibrated weir for the maximum allowable water depth, and allow table 1103.1 and 1103.2. The height of the stones or other granular material above the waterproof surface shall not be considered in water depth measurement, and the roof surface in the vicinity of the drain shall not be recessed to create a reservoir. Your roof design, where controlled flow roof drainage is used, shall be such that the design roof live load is not less than 30 pounds per cubic square foot. 30 pounds per square foot, to provide a safety factor exceeding the 15 pound per square foot represented by the depth of water stored on the roof in accordance with table 1105.1. Scuppers shall be provided in a parapet wall. The distance of the scupper bottom above the roof level at the drain shall not exceed the maximum distance specified in table 1105.1. 1105.12, excuse me. The scupper openings shall be not less than 4 inches high, have the width equal to the circumference of the roof drain required for the area served, just like in table 1103.1. So, looking at this really quick. Well, let's do these first. Okay, sorry. The flashing shall extend above the top of the scupper. At a wall or parapet, 45-degree cants shall be installed. In other words, at the wall, you have to put, it's called a cant. And it's more of a, yeah, we'll do it this one. Okay, let's see, right there, perfect. So we have a wall that comes down, right? And let's say this is the base of the wall. We have roofing material that's coming in. We have to put in a 45-degree cant like this, so that water doesn't sit there and collect right inside here. It'll always kind of slide out, okay? So that's what they're talking about. Separate storm sanitary drainage systems shall be provided within the building. Calculations for the roof drainage system shall be submitted along with the plans to the authority for approval, because you're putting standing water on a roof and it's slowly dissipating out. Here's your flow maximum roof water depth. If it's a flat roof, your water depth at the drain is 3 inches. Okay. Your roof, the roof rise, and the roof rise is right here. It's the vertical measurement from the roof surface at the drain to the highest point of the roof surface served by the drain, ignoring the local depression immediately adjacent to the drain. So if I have a roof rise of 2, then I can have a maximum depth of 4 inches. And you can see this, and there's never any more than a 6-inch depth. Okay? Because 6 inches of water, that's a lot. Okay? And then here's the distance of your scupper, the bottom of the scupper. And you notice the numbers are the same. Okay? Because they're telling you, if you're going to put a scupper in one of these building deals that's supposed to retain, we'll look at 6, right? You have a roof rise of 6, you have 6 inches above the roof level at the drain. So you can have 6 inches of standing water while the drain slowly receives the water. That's 6 inches of water retention. I have to have a scupper there so it doesn't go above that. So it makes sense to put the scupper on the side of the building the same height as the maximum level of standing water. Setback roofs. Drains on a setback roof shall be permitted to be connected to the controlled flow drainage system, provided that the setback is designed for storing water or the square footage of the setback drainage area is converted as outlined in section 1105 to gallons per minute, and the stormwater pipe size of the controlled flow system is based on the sum of the load. The branch from each of the roof drains that are not provided with controlled flow shall be sized in accordance with table 1103.1. And then you have the engineered storm drainage method, engineered storm drainage system, and it's just like a storm. It's just like the waste or sanitary drainage system. It has to go to the authority for approval. Testing. I believe that's the next section here. Oh, first off, siphonic roof drain systems. The design of a siphonic roof drain system shall comply with ASPE 45. Siphonic roof drains shall comply with ASME A11269. So what they're talking about is they want a roof drain system that actually is built and designed on siphon, where it siphons out everything. Gets to a certain level, and then all of a sudden it just starts to suck it out. Okay. Testing. New building storm drain systems and parts of an existing system that have been altered, extended, or repaired shall be tested in accordance with section 1107.21 or 22 to disclose any leaks and defects. So here's 1107.2, your method of testing. Except for outside leaders and perforated or open jointed drain line, drain tile, which is the subsoil, right? The piping of a storm drain system shall be tested upon completion of the rough piping installation by water or air, except that plastic pipe can't be tested by air. We talked about that earlier. The authority shall be permitted to require the removal of a cleanout plug to ascertain whether the pressure has reached parts of the system. I can't believe they had to put that in there. I'm being sarcastic. They put that in there so that us, the plumbers, know that an inspector can at any time say, I don't trust you, I don't believe you, open up that cap, open up that cleanout plug, and then watch him just get splooshed. Okay? One of the following test methods shall be used in accordance with section 1107.21 or through 2.3. The water test. After piping has been installed, the water test shall be applied to the drainage system, either to the entire system or sections. And this is all going to be pretty much identical to the sanitary, okay? Where it's applied to the entire system, all openings in the piping shall be tightly closed except for the highest opening. And the system shall be filled with water to the point of overflow. So now you're filling it all the way up to the roof, and you're watching the water come up to the roof itself. And that's where you go. Where the system is tested in sections, each opening shall be tightly plugged except for the highest opening, and no section shall be tested with less than a 10-foot head of water. In testing successive sections, not less than the upper 10 feet of the next preceding section shall be tested, so that no joint of pipe in the building except for the uppermost 10 feet of a roof drain system, which shall be filled with water to the flood level rim of the uppermost roof drain, shall have been submitted to the test of less than 10 feet of head. So you just keep going, 10-foot head, 10-foot head, 10-foot head, until you get to the top where you just fill it to the roof, and that's it. Okay? The water shall be kept in the system no less than 15 minutes before the inspection starts, and the system shall then be tight. Because the inspector's not going to show up and sit there and watch it for 15 minutes. They can, but they probably won't. Air test. The air test shall be made by attaching air compressor testing apparatus to a suitable opening after closing all the other inlets and outlets to the system. Force the air into the system until there's a uniform gauge pressure of 5 pounds per square inch, or sufficient pressure to balance a column of mercury 10 inches in height. This pressure shall be held without the introduction of additional air for not less than 15 minutes. And then the exceptions are where circumstances exist that make air and water tests described in section 1107.21 and 22 impractical, see section 105.3. If you want, we can go back to 105.3 and we can talk about it real quick. But essentially what 105.3 says Hey, look at that, it's right there. Plumbing system shall be tested and approved in accordance with its code or the authority having jurisdiction. The test shall be conducted in the presence of the authority. No test shall be required where a plumbing system, part thereof, is for exhibition purposes, so we're not doing that. But, right here, right up here, the authority shall be permitted to make such inspection as deemed advisable in order to be assured that the work has been performed in accordance with the intent of the code. The joints and the connections in the plumbing system shall be gas tight, watertight. What an authority having jurisdiction or an inspector will do in some cases is he will go ahead with approval if you do like a running water test. It's like, I can't get this thing on test. There's no way to do it. Just do a running test. So he's going to make you throw a bunch of water down the drain, and he's going to watch to make sure that it doesn't leak. Okay. So these are the tables. This is what we got going on. And it's going to be very brief because, like I said, this all gets covered in chapter, in Plumbing 3. Sizing a roof drain, leader, and vertical rainwater piping. So here's maximum allowable horizontal roof area. Okay. So you have all your square footages and everything. And you also have another one, which is called your GPM, or your gallons per minute. There is a way to calculate the gallons per minute of the square footage based on the rainfall. Okay. So if I say, let's say I have 140 gallons per minute. Okay. That's going to fall under the 192, which is 4-inch pipe. So if I have 193 gallons per minute, my pipe size is going to be 5 inches. And believe it or not, they make 5-inch cast iron. So the 5-inch cast iron, the 5-inch pipe that I've used has exclusively been on storm drains. Okay. This is the sizing of your roof drain, the leader, and your vertical rainwater piping. Vertical. Okay, so this is the size of the roof drain itself. This thing. That is a roof drain body. I'm sizing this bad boy, and I'm sizing the vertical coming down. This is going to give me the sizes for that. This side over here is the size of a horizontal rainwater piping system. And I have, and you'll be familiarized with the 3 different tables here. I have one for 1/8 of an inch per foot slope, right? I have another one for 1/4 of an inch per foot slope. And I have another one for 1/2 inch per foot slope. Okay? So that's what we're dealing with on that. Let's see, what else can I tell you? All of this, the sizing based on gallons per minute, because it's the easiest way. There's 2 different ways of doing this. The easiest way is just taking your gallons per minute. But in order to do that, you still have to find the square footage of the water that's going into that section of piping, okay, into that roof drain. But, and we're going to talk about this briefly, and then we'll end the lecture for the night. We're going into Appendix D, and we're going to talk a little bit about this table. Maximum rates of rainfall for various cities, and it goes through several different cities throughout all 50 states. And this is the maximum rate of your rainfall. This is all based on a 60-minute duration and a 100-year return. So in other words, over the last 100 years, this is what we got, right? And we're going to size it based on your gallons per minute and how many inches per hour that you have. Okay? So you're going to pick, here, let's pick San Diego. San Diego has 1.5 inches of rain. And that's 1.5 inches of rainfall that we can get and accumulate in 1 hour. Okay? Look at Palmdale. Palmdale gets 3 inches per hour. And Palmdale is a flippin' desert. Okay? But they can get that much rain. Or 0.031 gallons per minute per square foot. Okay? So if I have 1,000 square feet, how many gallons per minute am I going to have in a place of Palmdale? So Palmdale, which is 3 inches per hour, has a total gallons per minute per square foot of 0.031. If I have 1,000 square feet, I'm going to take 1,000 and multiply it by 0.031, and I'm going to get 31 gallons per minute. So Palmdale, and with a roof that is kind of exhausted my open space. So I have my roof drains, and I have a roof system that is 1,000 square feet. Okay, so that's my roof, 1,000 square feet. This is my roof drain. Okay, in Palmdale, that is 31 gallons per minute. Palmdale. Piddle. 31 gallons per minute. San Diego has a rate of 1.5 inches per hour, or 0.016 gallons per minute per square foot. So I'm going to use, in my gallons per minute, not 31 gallons per minute, but 16 gallons per minute. 0.016, right? $16 gallons per minute. Okay? Per square foot. Now I can go back to that table in chapter 11. This guy over here. And let's say I'm sloping it at 1/4 inch per foot. My first one was 31 gallons. And here, actually, let's do, it's not going to matter. So each one, I have Palmdale, 31 gallons per minute. San Diego, 16 gallons per minute. All I have to look at is right here, gallons per minute. 31 gallons per minute. 3-inch pipe. That's it. So the hardest part is calculating your square footage and converting it into the area's gallons per minute based on the area that you're serving. So yeah, that's pretty much it. That's all of chapter 11. So really, we're done for that, and the next video will be chapter 12. Until then, have a lovely evening.